Okay, welcome everybody. Thank you for coming here. We'll just start it. My name is Suyash. And looks like some of you are familiar with InfluxData. I work at a company called InfluxData, and I work as a developer advocate there. So in the past, I was a software engineer for 10 plus years in California, and working at Oracle and a company called RingCentral. Then I came to London, and we have a big presence. InfluxData is headquartered in California, San Francisco, but in Europe we have a large presence, a lot of customers, so I work in London. We will talk today about Unis Energy Storage. It's a dynamic company in Germany, and essentially I'll give you their case study and how they used InfluxDB, which is our database. Here's my contact, and if you like to share on X or Twitter, feel free to tag me or hashtag the conference, and I'm sure that will get shared. So who is Unis? So Unis is our customer. They are a pioneer in decentralized energy transition based in Germany, focus on large-scale storage. Their customers are energy supplier to residential areas, and they have an intelligent energy management system, IEMS. I'm sure you're familiar with these things at the energy conference. A lot of you guys might be working at your own companies doing similar projects. So just a picture to illustrate what Unis does. So they work with their customer, UV, and they work on locations such as these. Renewable energy, large scale, you can see a wind turbine, and a lot of systems in operation. So they are measuring all kind of metrics from these systems. Here we can see power, capacity, and they have their smart power, intelligent energy management system in place. And they have they're working with a lot of customers who have such like plants. So Unis's business, basically, I'm going to focus on the technical challenges. So they have this system, intelligent energy management system, and they needed more real-time data and historical data for their system, for their clients. Some of the other limitations they had was because they were running on a legacy architecture, it couldn't handle scale essentially very well. There were also issues with synchronizing data. So a lot of the data that was being captured at the plant, different sensors, that had to be stored in the cloud. It had to be shown as a report. And now imagine if you're looking at a report, but that is unreliable. The data is not correct, or it is too old, it's not real time. A lot of these challenges they were facing. And then of course storage, because they were doing things on-prem, storage challenges with that. Key business goal were essentially getting real-time insights of plant systems such as batteries, sensors, other modules that were critical for their client. Why? Because they wanted to make decisions on energy trading, maintaining battery, various other things. So overall, what they were really due for was a re-architecture of their own system. And within that, our company's product played a key role. So that's where InfluxDB comes in. So I work at InfluxData. It's a company that basically the flagship product is a time series database called InfluxDB. I think some of you use it. If those who are not familiar, time series database is a specialized database for storing data related to basically time measurements. Why you would need something like this? Well, if you want to monitor any kind of like industrial IoT, kind of like an energy management, like a plant operations, which gives a lot of metrics, all these sensors, even in this building, like, there is HVAC system here. It's giving you all kind of data about what the temperature is, lighting, all that data. And you want to measure that in real time when these large scale systems are in place. So they're also, used in warehouses, if you're doing industrial robots, green energy database, time series database is used all kind of places. It's specially designed to ingest high amount of streaming data at nanosecond precision, which is really, really small. Nanosecond is very small. Because so much data comes, you also want the data to be compressed, because a lot of the data, because it's coming at such fast rate, you don't really need that. You might need the latest data, but historical data, you want to archive it, save it, so it should be compressed. There is another thing called cardinality. Basically, you want to store essentially unique data points, and then you want to query based on time. That's where time series database really comes in. It's optimized for that, optimized for all of these things. And that's what InfluxDB does. So compared to other type of database, there is relational database. I'm sure you're familiar with them. Traditional database. I used to work at a big company, Oracle or PostgreSQL. There's document type storage, or also called NoSQL, like MongoDB. Databases are optimized for search, like Elasticsearch. InfluxDB is optimized for time series. Time series, essentially, like I was telling you, all this data from sensors, so they can be in form of metrics, all these metrics that you want to show in a dashboard, or particular events that you want to track. Like something happens, you want to know exactly what time what happened, like an anomaly or some other kind of event. You want to do analytics. It's optimized to do all of this, and it's open source. You can get it. It's on GitHub, MIT license, and a third-party company called DB Engines. They do very much like a comparison metrics of all the database. And within the time series database, InfluxDB is ranked #1. So that is our company's product. It is designed for time series, so scalability, designed to scale for large volumes of data, large ingestion, like I explained earlier. It's distributed, so non-blocking high volumes. Data can come from multiple sources, and it doesn't block the operation. It's available. These are the benefits of cloud. It's managed for you, and it's flexible. Flexible schema on write, which is particular database thing. If you have any question about this, please ask me towards the end, or just ask me when I'm walking around, and I'm happy to answer. So the database is the core, but it has a lot of components to it. And it's built on top of open source technology. So basically, there's the storage layer at the very bottom, and we use something called Parquet, which is an Apache open source project called Apache Parquet, and it basically allows for a very optimized file format. That is where all the data is stored, so that it can be queried really quickly. So there is a query engine, there is an ingester because you want to ingest large volume data, and then you want to have this data. Basically, you want to do something called compaction. You want to store this data efficiently so that it can be queried faster, because a lot of the data can be for just archival reasons. So InfluxDB underlying, we use a lot of open source project. This is Apache Arrow. It's for in-memory columnar analytics. Apache Data Fusion. This allows you to run SQL queries. And Apache Flight. This is for high-performance data transfer, basically, because you want to send it from the edge to the cloud. So essentially what I'm saying is, it helps developers become more productive. It has a lot of integration because it's built on open source technology. It's always improving. And one other key factor is called edge data replication, where imagine these are different industrial systems, plants, energy systems. All of them can have their open source version of InfluxDB. This is kind of what Unis had. They have a locally running open source InfluxDB, but when they move to the cloud, it provides something called edge data replication. So you want to, like I mentioned, they had one challenge was getting synchronizing data and showing the graph, the data visualization with the real-time metrics. To do that, because edge data is replicated and connected to the hub, which is the cloud, data is always synced, and it's reliable. So just want to mention some other things, because a lot of these things are open source technologies. We also provide something called Telegraf, which is basically an agent that can talk to technologies like MQTT or Modbus to get data from PLC or other systems. And then here are, like, for example, this is very typical. You can see industrial IoT. You can think of like ecosystems, so manufacturing, industrial assets. They talk to something called Telegraf, which connects to that system. It's an open source tool, talks over these protocols. And then all of that data comes to InfluxDB, the database. And then from there, it can be queried, of course. It can be written to it. But you can also do data visualization, and you can do machine learning. You can store this further into a data lake. And then there are other tools that work with our database, different middleware technologies, et cetera, et cetera. We have libraries to build your custom application that can talk to the database, client libraries. So this is what UNIS system kind of looked like at high level. So, we saw one of the example of their customers, like plant, you can say energy management, or energy like wind turbine. And the system has a lot of sensors, as you're familiar with: temperature, battery, maybe some other sensors like light, pressure, all different kind of sensors that, again, collecting all kind of data using PLC and networking protocol like Modbus, sending it to something called Telegraf. And they were using InfluxDB open source version. And then this is what we added later on, but that's all that they had. And they had their own server where they were storing. So if we look in detail, at simple level, this is what it kind of looked like. And this is what was causing a lot of these issues related to data challenges for getting real-time insights. Because, this is how a lot of people get started. They use the open source version. It works to a certain level, but it starts giving problems. When, especially you're looking to scale, so they wanted to send about 50,000 data points from their PLC controller. Battery information had a lot of data. Again, this is coming from multiple batteries. Data, 80,000 data points became infeasible, unreliable, and then they lacked data replication because they just had one instance of the open source database running. The architecture after looked like this. So here we have the PLC controller and other modules connected to the open source tool. It's called Telegraf. That Telegraf can take all this data. So the data can be stored in Telegraf, and the plant server talks to Telegraf, and it can also query the data, right? Then Telegraf can also take data as input, but it can also write data. It can also provide output. So that was sent to InfluxDB, the one running locally on site, the open source one. But then we had something called InfluxDB. We saw this earlier, edge data replication. That allowed data to be stored on InfluxDB Cloud. And they were on initially they were on V1 of our database, which is an older version of our database, and they moved to V2. And now finally they are running open source, but they're also running on the V3, the latest database. It's called open, it's the dedicated version because it's single tenant dedicated to them. So it provides better compression, much larger storage capacity. It removed basically all of their problems. And I will show you a little video from the architect himself who works at UNIS in a little bit. So let's look at that because unfortunately, Ricardo couldn't be here, but I asked him kindly if he can send a video. So I'll just play a quick video, and this is the person who implemented all this thing working with our team.
Hello, my name is Ricardo Kistja. I'm the head of IT infrastructure and IT security at UNIS GmbH, and I hope you all have a lot of fun at the Energy Summit. I wasn't able to make it, but I still wanted to provide a small video to give you an update on how we did evolve our system, mainly using Telegraf, Influx tools, and a bit of Docker and container automation. So what you can see here is basically infrastructure monitoring based on Telegraf ping input plugin. It's basically querying the devices of the plant continuously and gives us an overview of how is the plant. Is it healthy or is it having issues? And it's actually quite nice. So we have most type of infrastructure monitoring with Telegraf a lot. for server CPU, server log files, all of that. It's actually quite easy to set up and quite valuable information. But now let's go to the plant. So this is an overview of the plant monitoring system as it was, or as we have it still. It gives you overview of like available units, batteries, and grid information, and it gives you a short overview of everything based on technical unit level. What does technical unit level mean? We have basically multiple technical units, and each of them has like multiple racks of batteries and multiple modules, obviously. And with like the plant, we are limited to having averages per TE across all racks, across all modules only. So you get the system average, SOC or the voltage min and max across the technical unit, but you don't get any more details. You can't go down, But with the battery data directly from the battery, you are able to actually go down the rabbit hole and add more insights and more level of details. For example, like this dashboard shows basically the available technical units from plant, and then it shows you all of the information based on the racks, based on the rack voltage, and the temperatures, the rack currents. Sorry for that loading issue. But it's actually quite nice because all of that insights are not even possible with just the plant monitoring system, because it has constraints on how much data points it can handle, how much data it can handle. It's not able to write directly natively to Influx, so I need to pick it up, the data from the device, and it's a whole bunch of like oddness. While with Telegraf I was just able to throw in the data point lists and basically query devices directly and to get all of what's available information out of it, which really is nice and great. And
So Telegraf is one of our open source projects, which when you use Telegraf, it made it easier to get all this data points, thousands of them, tens of thousands of them, directly into InfluxDB using Telegraf. It's an open source tool.
I wanted to give you that small insight, and maybe also like to round it up. So imagine you have like a TE with like 4 racks, and 2 of those racks have like 60 degrees Celsius, and 2 of those racks have 30 degrees Celsius, and you would end up with like an average of 45 degrees Celsius, and you would think everything's fine. But those 2 racks with 60 degrees actually are an issue because they actually are too hot. And that information or understanding of information is not even possible if you just have averages across a complete technical unit, but you need the insight level for that. And that's why it's so important and critical to collect all of those information points. And that's why we are doing it. And we are happily collecting a bunch of data. So we did collect in the last 4 weeks 400 gigabyte of battery data in Influx version 2 OSS on the server's local plant PC. And we are sending this data to our version 3 cluster. And on the version 3 cluster, it's only using up 40 gigabytes. So it's like a 10 times better compression rate compared to Influx OSS 2. And that means, plus the reduced storage costs with Influx version 3, that means I can collect all battery data and I can save it, and I'm not creating a bunch of headaches for finance because server costs are exploding. No, everything is cheap, but still available, reachable, and working fine, and that's actually great, and that is only possible because of Influx and the Telegraf system. And I'm really happy about it. And if you would like to know more about this, feel free to reach out to me.
Some of the closed captioning was messed up, but essentially, you saw what he said. He showed the real-time visualization like a Grafana dashboard, data coming from InfluxDB. InfluxDB, when he said cluster, it is our cloud offering. And then he's using both open source and cloud dedicated, taking advantage of both cloud offered storage cost compression, saving him.
Hello, my name is Ricardo Christian.
So let's go next. So this is the recap. Essentially, it was a smooth integration because both of them are, essentially at the heart InfluxDB. One is running on the cloud, more optimized, had more bells and whistles. A lot of the legacy challenges went away because they stopped managing their own hardware and using the older version of InfluxDB. Cloud benefit, high availability and reliability. Also using the edge data replication capability. Stable performance, good for the IT team, good for the business. Scalable solution, now they're scaling, this company is growing, so they operate at more complex customers who have more dynamic needs and more complex systems in place. And then the cost of storage actually came down. And that's it. If you'd like to give it a shot, I only have 30 minutes. I generally like to show a live demo of code, but today I will point you to a lot of resources. The whole case study is documented here as a white paper. You can read our blog. If you want to learn about InfluxData, we have free training. If you want to learn about hybrid cloud architecture, it's also very interesting. How do you use open source and cloud together? That's a nice course. Community you can find. I'm happy to answer. You can contact me. But yeah, give it a shot. It doesn't cost anything. Available on major marketplaces. But also, without your credit card, you can try InfluxDB Cloud for free. And with that, here's my contact. You can also connect with me on social media, LinkedIn, or Ricardo. He said he's open to being contacted, ask him any questions about his system, whatever he can share, he'll be happy to answer your questions. And with that, that's it. I'll take any questions. Thank you. Yes, please. Maybe. Yeah.
Thank you. Hi, my name is Sebastian Lafleur. I'm a freelance software engineer. I've actually used InfluxDB in the past as well. Version 1 I've noticed that so in InfluxDB, when you actually add data points for the people who are unfamiliar, you also add a bunch of metadata. So for instance, which sensor the data point came from. However, for each measurement, you have to repeat that specific value, which means that you have a lot of replicated values in your database. I know that in V1, that did not get deduplicated. With V2, I stopped using it because of the known issues of stability and with the Flux query language. I am very enthusiastically waiting for Influx 3. Do you perhaps have any news to share on that front? Because I know it's up and coming, but it's not here yet.
Yes, so a lot of things that you would know. You work at a company that if they're not public, I won't be able to say that at this stage. It is committed by our CTO. He has mentioned that it is coming, so it is coming soon. That's all I can say. Because the InfluxDB 3, it is available on the cloud right now, the open source version. Yes, it is coming in one shape or the other very soon. So if you're coming from version 1, it would be easier, seamless, because like you mentioned, the Flux query language, it actually has now support for standard SQL, so you don't have to learn this query language. It has much more other features as well. So yeah, I'm also excited and waiting for that because I talk to our developers a lot, and yeah, it's a common question. But very soon, hopefully, you'll hear something. Yeah. Any other questions? In general, about data, happy to answer. Doesn't have to be Influx or anything else. Any comments? Anybody want to share? Or would they use their systems? If not, well, thank you again. And you can find me around. You have a few minutes before the next session, so thanks again.